Determine the general solution to the following equation. Sine of x divided by 3 is equal to cos of x divided by 3. Now, as this equation stands, there's two trigonometric functions present, sine and cosine. And whenever we attempt to solve these by hand, we need to get it to the stage where there's only one trigonometric function present. So to do this, we need to remember that tan of an angle theta is in fact equal to sine of the angle theta divided by cosine of the angle theta. So because both sine and cosine have the same angle, x divided by 3, if we divide both sides of the equation by cos of x divided by 3, we will turn this into an equation involving tan. So this equation is actually going to become tan of x divided by 3, and it is going to equal, so that's the left-hand side, that's sine divided by cos gives tan, and now on the right-hand side, if you have cos divided by cos, that is just going to equal 1. And now this is an exact value you should know for tan, so its reference angle is theta is equal to pi on 4. So pi on 4 is this angle here, and if we extend it to hit the tangent line, the y value that you get is 1. So that angle there is pi divided by 4. The other place in the unit circle where tan is also positive is in the third quadrant, and that is pi plus pi on 4. However, because we're finding the general solution, it doesn't really matter about that second angle, because what we're going to find is that it is a period between each of the solutions. So if we take one solution and add the period on, we get another solution. Add another period on, we'll find another solution. So because of that, we're just going to find one particular solution. So we want x divided by 3 to equal theta, so tan in the first quadrant. Therefore, we're going to find x on 3 is equal to pi on 4. And if we multiply both sides of the equation by 3, we find that x is equal to 3 pi divided by 4. Now that we've got one specific solution, and we know that each subsequent solution is just a period added or subtracted on from that, we can develop a general solution. So the general solution is formulated by taking one specific solution, which is 3 pi on 4, and then we add on the period multiplied by a new parameter k, where that value of k is an element of the integer set. So those numbers that k could take on are things like -3, -2, -1, 0, 1, 2, 3, 4, etc. So that k essentially stands for adding or subtracting on a certain number of periods each time. So the period of any tan graph is equal to pi divided by n, where n is the value that's multiplied by x in here. So in this case, n is equal to 1/3. So that means our period is equal to pi divided by 1/3, and that simplifies down to 3 pi. So that means our general solution is x is equal to 3 pi on 4, a specific solution, plus the period, which is 3 pi, times the parameter k to indicate that we could add or subtract on any amount of periods and we would still get another valid solution. And that is for k is an element of the integer set. So that is what we would call the general solution to an equation. Now over on this slide, we're going to have a little bit of a look at the graphical interpretation of what we've just done. So we started off with sine of x divided by 3 equals cos of x divided by 3. And by dividing both sides by cos, we got that to be tan of x divided by 3 is equal to 1. So our first graph represents sine of x over 3, which is in blue, graphed alongside cos of x divided by 3, which is in red. And you can see that there's a number of solutions. Of particular importance is this solution here, which is 3 pi on 4, and that was the one specific solution that we found on the previous slide. All other solutions will just be a period more or less than that value. Our second graph has y equals tan of x divided by 3, graphed alongside y equals 1. And again, we can see the points of intersection between those curves are the solutions that we found before. So again, here is 3 pi on 4, which is a solution. And now you should see that all of these solutions match up. So wherever there's a point of intersection between sine and cos on the first graph, there's also an intersection point between tan and y equals 1 on the second graph below. Now, just before we finish up, I think it would be useful for us to explore what this general solution actually means. So we have x is equal to 3 pi on 4, which is a specific solution. It's 3 pi on 4 in yellow highlight here. And then it's plus 3 pi k, where k is an element of integers. So what happens when we change k? So if you have a look, if k equals negative 2, what this does is it gives us x is equal to 3 pi on 4 minus 6 pi, because 3 pi times negative 2 gives negative 6 pi, and that will give us the point negative 21 pi on 4, which is this solution down here. So k being negative 2 says that what we've actually done is we've taken our specific solution and we've subtracted 2 lots of the period to find a new solution. So if k equals negative 1, we get x is equal to 3 pi on 4 minus 3 pi, and that's minus 9 pi on 4, so that's this solution here. So again, what we've done is we've taken our specific solution and subtracted 1 times the period to find another solution. If k equals 0, we have x equals 3 pi on 4 plus 0, which is just 3 pi on 4. And that there is the specific solution that's in the yellow highlighter. Finally, if k equals 1, we're going to add 1 lot of the period on. So here we have x is 3 pi on 4 plus 3 pi, which goes to 15 pi on 4. And that's the same as starting here and adding 1 period on to find the next solution. And of course, k can take on any value, so we could add 10 lots of the period on and find yet another solution for this equation.